topic today is spherical mirrors. What are spherical mirrors? To define a spherical mirror, we will have to consider a glass hollow sphere. A glass hollow sphere. ग्लास का बना हुआ एक गोल बड़ा सा गेंद फर्ज करना पड़ेगा and we will cut its small portion और इस hollow sphere का एक small portion अगर कट कर तो जो पीस हमें मिलेगा वो पीस spherical mirror कहलाएगी बशर्ते कि इसकी one or two surfaces are reflecting. मसलन इसको हम देख लेते हैं कि कैसे होगा ये। तो फर्ज करें ये आपके पास एक ये हॉलो स्फीयर है, गोला है। हमने क्या करना है कि फर्ज किया इसका एक पीस यहाँ से कट करके सेपरेट कर लें। ये हमने सेपरेट कर लिया। ये स्फेरिकल मिरर कहलाएगा बशर्ते कि इसकी ये बाहर वाली सरफेस रिफ्लेक्टिंग हो और या ये इनर अंदर वाली सरफेस रिफ्लेक्टिंग। So consider we have a glass sphere, glass hollow sphere. We cut its piece and this part or this portion will be called spherical mirror if its outer surface is reflecting or in a second case its inner surface is reflecting. Then this portion of this glass hollow sphere will be called a spherical mirror. Now, how it will reflect the light rays? Here, this is our spherical mirror. And what happens? First, we paint silver on its inside. Then second layer of red lead oxide is painted. Now what happens? Its inner surface is opaque. अंदर की surface opaque है, यानी reflection नहीं करती. And its outer surface is reflecting because of the silver layer. So this type of spherical mirror will reflect the light rays which will fall on its outer surface here like this. But how will these reflect? These will hit it and these will bounce back. How will this geometry we will make? We will study this geometry when we will be studying the terminology used in spherical mirror after a short time, now during this lecture. So you got this type of spherical mirror is called convex spherical mirror. Why? Because its outer surface, convex surface, is reflecting. There is second type. If consider we have a spherical mirror such that we first painted silver on its outer surface. Then we painted a second layer of red lead oxide on this silver layer. First we painted silver layer and then we painted red opaque red lead oxide on that silver. Now what happens? It's this side is opaque. Opaque means जिससे रिफ्लेक्शन ना हो सके, and this inner side will reflect. Why? Because of silver. Here, because of silver, these light rays will reflect. These will hit this spherical mirror and then bounces back into the same medium, converging at some point. So this kind of spherical mirror is known as concave spherical mirror. And as these light rays are converging at a point, therefore this is also known as converging spherical mirror. So we have two types. Number one, convex spherical mirror, and number two is concave spherical mirror. Convex spherical mirror and concave spherical mirror. And as in convex spherical mirror, all the light rays hitting it are diverged. Therefore, it is also known as diverging spherical mirror. And here in case of concave spherical mirror, we see all the light rays hitting it are converged at a point. Therefore, it is also known as what? Converging. Converging spherical mirror. So again I will repeat it. We will have to define what is spherical mirror. So we will define it in this way, that a part of hollow glass sphere which is reflecting either from external surface or from inner surface. Again, what is spherical mirror? Spherical mirror is part of a hollow glass sphere whose surfaces are reflecting. Next, there are two types of spherical mirror. Number one is convex spherical mirror. How? If we have a spherical mirror such that its inner surface is coated with silver at first, and that silver layer is then again painted with a red colored lead oxide over it. So we have got two surfaces, one of silver and other of red colored lead oxide. Red colored lead oxide surface is opaque, that is non-reflecting, and the other surface which is made up of silver from this side it will reflect the light rays as its convex side is reflecting. Therefore, it is known as convex mirror. And there is another thing. All the light rays which fall on its convex surface, these are diverged, diverged here and there. Therefore, it is also known as diverging mirror. Now we come towards the second type, and second type is concave spherical mirror. What happens here? We will define a concave spherical mirror is a mirror in which external convex surface is painted with silver. Here, first layer is layer of silver on this external side, and second layer comes which is made up of red lead oxide, and that is opaque, non-reflecting. So its convex surface is non-reflecting and its inner concave surface is reflecting because of silver. So when all the light rays which fall on this inner surface, these are converged, इकट्ठी हो जाती हैं एक point. These are converged at a point. Therefore, it is also known as converging spherical mirror. It has two names. Concave, you see, it's like a cave, a small cave. It's like a cave. Therefore, it is concave mirror. It is also known as converging mirror. Why? Because it converges all the light rays falling on it. So these were the two types of spherical mirror. Now we will study certain terms used in this topic. And the first thing is pole. What is pole? Here you see again we have the same convex mirror, or here concave mirror. This is the curvy portion and this is the midpoint of the curvy portion. Here again it is a curvy portion, curvy surface, and the midpoint is over here somewhere. This midpoint of curvy surface is known as pole, capital P. Here also capital P. So you got the point. The midpoint of curvy surface is known as pole. The midpoint of this curvy surface is known as pole. Now we will define another term, and that is what is center of curvature. You see, first we studied pole, and now at number 2 we are going to study center of curvature. What is center of curvature? Again we will come towards the definition of spherical mirror. This spherical mirror is part of hollow sphere, and the center of that hollow sphere is now called center of curvature for this spherical mirror. Here, approximately. Okay, I measured it in this way. I measure here and then this. The center of that spherical mirror is now the center of curvature C for this spherical mirror. So how we will define? We will define it in this way that the spherical mirror is part of a hollow sphere and the center of that hollow sphere becomes center of curvature for a spherical mirror. So is it clear? The third definition is also easier. This is the radius of the hollow sphere, and that radius of hollow sphere will be called radius of curvature for this spherical mirror. Again, how will you define the third term? Third term is radius of curvature. What is radius of curvature? Again, we will define in the same way. This spherical mirror is part of hollow sphere. The radius of that hollow sphere is now called radius of curvature for this spherical mirror. Okay. Now the fourth term arises over here. How we will use 2 points. One is this is pole P, and here this is center of curvature. This is pole P of this spherical mirror, and this C is center of curvature for this spherical mirror. Now we will define principal axis. How many terms? We defined 3, and now 4 is what is principal axis? What is principal axis? Line joining the here line joining the center of curvature and pole P is called principal axis. You got the point? The line joining the center of curvature and pole P is called principal axis. Now at number 5 we will define principal focus, or just simply focus. What is principal focus or just focus? There are two cases to define focus. Number one is if we have concave mirror, then what happens? All the light rays which fall on this concave mirror, these converge at a point. This point is known as principal focus. Okay, and as this principal focus F is in front of this concave mirror, therefore it is real focus or real principal focus. Its second case is it was principal focus, real focus, and now we will come towards virtual focus. What is virtual focus? Now consider we have a convex mirror. What happens in case of convex mirror? All the light rays falling on it are diverged. But how we will diverge these? First of all, we will get an idea that from which point these are diverging. First of all, we will create a dotted convergence, imaginary dotted convergence. Now we will make divergence. At first, we got the idea by making convergence, imaginary convergence, and now we are making how these will diverge. So when the parallel light rays, which are parallel to principal axis, fall on this convex mirror, these seem to be diverging out from a point. Behind this, we are coming from this side, so it is now behind, and this was in front as the rays were coming from this side. So after reflection, this was in front, and now what is happening? Rays are coming towards it and then bouncing back into the same medium, but this point where it seems as if these light rays were diverging out from the point, this point is inside this convex mirror. Therefore, it is known as focus, but this focus is virtual focus. This is virtual focus and this is real focus. Just to make a distinction, we used negative and positive. These are not used in your syllabus. Yes, these negative and positive are used in the distance of this principal focus from the pole. You may say negative f. This is the focal length. Here we use negative f, and here what we will use? Positive f. Positive f for focal length. And what is focal length? The distance between focus f and pole p is called focal length. Here, the distance between pole p and principal focus f is known as focal length. It is negative if it is convex mirror, and focal length is positive if mirror is concave. So these are the five terminologies which we have to use. I will repeat it, but first of all, we will define what is spherical mirror. Spherical mirror is part of a hollow sphere made up of glass and whose surfaces are reflecting. Either outer surface is reflecting or inner surface is reflecting. It will create two types of spherical mirror. Now, if outer surface of a spherical mirror is reflecting, then it is called convex. Then it is called convex mirror, and as it diverges, all the parallel light rays falling on it. Therefore, it is also known as diverging. Di- Diverging mirror. The second type is in which all the light rays are converged at a point. If its inner side is reflecting, then it is known as concave spherical mirror. And as all the parallel light rays falling on it are converged at a point, therefore it is also known as converging spherical mirror. You need not to describe how it is made, that is by using first coating silver on its external side and then making a second coat of red lead oxide over the silver surface, and here painting silver on its inner surface at first and then painting red lead oxide over that silver surface. You must know these things, but you will not have to describe it in the definition of convex mirror or concave mirror. You just tell them that if external outer surface is reflecting, it is convex mirror. If its inner surface is reflecting, it is concave mirror. And why it is called converging mirror also? Because all the parallel light rays which hit its inner surface, these are converged at a point. That's why it is known as converging spherical mirror. And what happens over here? Here you will tell that all the light rays which fall on its external surface, these seem as if these are sorry these seem as if these are emerging from a point inside that uh, convex mirror, and these all light rays diverge, and therefore it is also named as diverging spherical mirror. Now we will come towards the definition of pole. What is pole? The midpoint of curvy surface is known as pole. That's all. Either it is the case of convex mirror or concave mirror. In both cases, the midpoint of curvy surface is known as pole. What about center of curvature? We will define that the spherical mirror is part of a hollow sphere. The center of that hollow sphere is now called center of curvature for this spherical mirror. Again, what is radius of curvature? The spherical mirror is part of a hollow sphere. The radius of the hollow sphere is now called the radius of curvature for this spherical mirror, denoted by capital R, and center of curvature is usually denoted by capital C. And now we come towards radius. What? Now, number 4. What is principal axis? Here, you just tell them that the line joining the center of curvature and pole P is called principal axis. And what is focus? In case of concave mirror, all the parallel light rays parallel to principal axis. All the parallel light rays parallel to principal axis are converged at a point. This point is known as principal focus axis. Or in case of convex mirror, all the parallel light rays parallel to what principal axis? All the parallel light rays parallel to principal axis after reflection diverge and seems to be diverging from a point inside the convex mirror. That point is known as principal focus F. In case of convex mirror, it is called virtual focus, and in case of concave mirror, it is known as real focus. And the distance between real focus and pole P is called real focal length, denoted by positive F. And here the distance between virtual focus and pole P is called focal length, but it is denoted by negative f, small f for focal length, capital F for focus. Small f for focal length, capital F for okay. So these were the spherical mirror and terminology used in spherical mirror. That's enough for today.